This is one of my favorite cases. It's been in the literature of the quality manuals for many years, but it still has relevance today. Is an effective quality assurance organization portrayed in this case? Well, effective is an interesting word. They certainly have strengths, which is power, and they're forceful, and they have standards that are enforced. But were they effective? Did they accomplish what was supposed to happen on this particular project? If you look at the weaknesses, it's certainly unrealistic. They lack the big picture. If anything, they're nitpickers. They do not add value. We oftentimes think of them as a standards police. That's not what we want from a QA function. Our idea here is not to burden the project, or the organization for that matter, with a series of standards that are unusable and do not provide value. If you look at what could have been done differently in the case, it's very simple. Basically, why are they inspecting so late in the process? So we know that they need, from a lessons learned perspective, to change the methodology. Earlier inspections in the process with time to recover if errors or standards are not found are appropriate. Identification of the trade-offs and the costs and benefits would have been necessary. What would you have done if you were individuals of any of those, the quality assurance team, the project manager, or the lone dissenting programmer? Well, if any one of them had looked at the variance and said, you know, we have a significant event here, we have really two choices. We can either scrub the mission, redo and start over, or we can ask for a variance to standards. Basically, those are the two things we can do. And those are the things that we should see. What is the cost and benefit associated with going at risk without making the change? What happens if we don't follow the standards? Or if the standard is that important and it really is critical, then do we need to go through the entire cycle again? And the answer to that would be yes. Scrub the mission, redo whatever code it is, and take it from the point so that adequate testing would have been done. It's a straightforward kind of analysis when you think about it. We'll try and apply some of those tools and techniques and give you some benefits that come from cost-benefit analysis and other techniques such as cost-benefit analysis. But make sure everyone is aware of the risk of changing code without testing. As I think we've said before, never lie to your superiors and don't surprise them. And we certainly did both in this particular example. What we're going to try to do then is apply modern project management and modern quality management, which complement one another. They both recognize the importance of customer satisfaction, managing and influencing needs so the customer's expectations are met or exceeded. Prior to that, project managers only looked at cost and schedule. Now, modern quality management and modern project management says we want to look at prevention over inspection. The cost of avoiding mistakes is always less than the cost of correcting them. So when we look at the diagram, we see that project quality management falls into planning, assurance, and control. Each of the elements has the standard work breakdown structure that we talked about in the first module. There are inputs, there are tools and techniques, and there are outputs. What we're going to do is highlight the ones that we think are most appropriate for projects today. Quality planning inputs. What do we do to plan for quality on our project? Well, we take the quality policy, is the overall intentions and directions of an organization with regard to quality as formally expressed by top management. The key area here is that if you do not have one, you need to create it, especially in a joint venture or task force. As more and more alliances are formed, you need to start to carve out or create a specific policy for your project because you may have a conflicting sense of values between the performing organizations. Now, the scope statement is something which we talked about in the beginning of this first module. It documents the major project deliverables as project objectives, and it also defines stakeholder requirements. So we're going to take the scope statement and our quality policy statement and start to think about what we need to do on this project to affect good quality. Part of scope is always product description. It includes all the details or technical issues that may affect quality planning, and also standards and regulations, which are specific requirements related to the application area. We need to include such things as organizational policies, outside standards from government agencies or other areas, such as building codes, all need to be brought into our planning process for quality. And anything else that is occurring on the project. For instance, there may be procurement activities which require certain conditions to be met. And part of the quality process is to ensure that whatever is specified in the procurement management plan are affected on this project. Quality planning is taking advantage of the cost of conformance, the pay me now aspect of what Crosby said. It tries to avoid the cost of nonconformance, the pay me later portion. The Japanese have a term called the moment of truth. It relates to the first time a customer comes in contact with a product or service. In our experience in project management, that relates directly to the first time an employee makes a judgment regarding quality. We talked earlier about the caterer example, where we try and identify upfront as early as possible what satisfies our customers. And hopefully those customers will become influencers and partners with us. The key to understanding this concept, and to be honest, if you're having trouble selling it to those above you or to whomever, is to look at something called the cost of fixed defect curve. The cost of fixed defect curve applies to any given industry. I'll use a pharmaceutical example, but you can use almost any industry and it has a similar approach. When we look at the steps necessary to create a drug, you'll find that there are early phases. They happen to be preclinical trials, clinical trials, subsequent investigation and marketing, and finally delivery of the drug. If you look at that step, each of those are these phase ends or kill points we talked about, stage exits. When we look at each one, for instance, in the very beginning, in the initial design, if we decide that we want to make a change, normally in the very beginning, it's an addition of a paragraph. When you're talking about feasibility or investigation, you may be talking about, $5 to $10 at most to spend some time to add a paragraph to say we should also look at this. Now, if you're in the research portion, in a drug business, it could cost hundreds of thousands, maybe even $1 million. So obviously you need to be as creative as you can, but also try and be as limiting. But the idea is it's still only going to cost $1,000 to $100,000 to $250,000 to maybe $1 million to add things. But what happens if you get to the end of this curve? What happens if you put that drug into the product and sell it, and all of a sudden now there's a problem with it? The liability issues could run into the hundreds of millions, if not more, and that's actually happened in several drugs. So any industry, be it information technology, networking, has its own cost of fixed defect curve. If you look at the life cycle, the cost associated with finding an error early in the process costs extremely less, orders of magnitude less, than the cost of finding it in the ultimate use or production arena. You should be aware of the cost of fixed defect curve. You should try and use it. You should look at the life cycle that you have and identify where are the inflection points, where do costs start to increase significantly. Whenever you see that, you should recognize, have we covered everything? We'll cover more of that when we talk about risk, but for now recognize that the cost of fixed defect curve fits perfectly with the cost of quality. The earlier we identify something in the process, the cheaper it is. The later we identify it, the more it costs. We also talked, when we talked about cost, of our ability to affect savings. As we move down the project life cycle, the ability for potential savings decreases. We can't do much. But notice how much it costs us to change. So that if we see a new technique or something that is new or beneficial, if we do not explore and identify when we could use it early enough, our ability to capitalize on that savings is diminished. And the cost to implement a change, should it be required because of consistency or a new spec or a new set of standards, increases significantly. So recognize that the cost-effective defect curve and our ability to affect savings over a project both work in concert. The earlier we are able to apply them, the better off we'll be. Now, as part of the quality planning processing, there are several tools. Benchmarking is one of the most common tools. It's basically used for product and process improvement. You can do it within the organization, and you can do it outside the organization. It's basically a process of identifying what other organizations are doing and measuring yourself against them. One of my frustrations at the information technology arena that I work in is that it's very difficult to get flat rate manuals. The contractor who comes to my house to replace windows can fairly accurately estimate how much it's going to cost to replace those windows. He or she can go to a manual and actually look at how much labor rate, what the relative cost of windows are going to be based on current prices, and identify how long it will take even to include the cleanup. I once worked with an organization that was providing estimates for building buildings. Their estimates were detailed, not only down to the floors, but to the front. And there was a checklist that had, does the building have a flagpole? And not only were the costs of the flagpole identified, there was also the costs associated with the rope and the pulley necessary. It didn't include the flag because it felt that that was an organizational issue. But the idea is that a flat rate manual, or something which helps us provide a benchmark, is an excellent way to manage quality planning. We've talked about cost-benefit analysis. It identifies the costs and benefits of performing quality management. It works the cost-effects-defect curve. Remember that you can apply it to intangible costs in a project as well. One other tool that we talked about is the cause and effect diagram, the Ask 5 Whys, also known as an Ishikawa or a fishbone diagram. It's a graphic way of identifying the potential problems on a project and asking why multiple times. Flowcharting and the cause and effect diagram are an effective tool also for quality planning. Here are some of the examples that you can use in asking why. Time, machine, method, material, energy, measurement, personnel, environment. Take each one and ask, why is this causing a problem? And then ask it again, and ask it again. And then ask it one more time. And what you will find, as you did in the process hunt, is there are things about your organization or project that you were not aware of. We call this root cause analysis. And the idea is to attack the cause, not the symptom of a problem. Design of experiments. Formal quality metrics are ways of identifying, and there are mathematical techniques for identifying which of the variables in a project are the most important. This is frequently applied to products on a project. An example might be you have determined that there will be some productivity gains for training. So you would pilot this and then identify, is in fact there a real gain, and where did the gain come from? And by seeing what aspect of the training created the most gain, you could then estimate and measure where you would get the largest gain. Key to the concept of project management is customer expectations, as we've said before. We will next consider the concept of ILITEs, the attributes of quality which are critical for customer satisfaction.